Hello friends! Today we're going to talk about solutions. The solutions we're talking about today are not the answers to a question or the solution to a problem. We're talking about homogeneous mixtures. We're going to learn what the difference is between heterogeneous and homogeneous, what is a solvent, what's a solute, what does dissolving mean. We're going to learn all kinds of fun things today, so strap in.
How does a tree grow? Why does the wind blow? When does a flower bloom? How can a rocket shoot to the stars or land up on the moon? It's science and technology, engineering, mathematics. Get smart, keep it simple. Let's learn about STEM.
First, we need to understand the difference between homogeneous and heterogeneous. A mixture is when you combine a bunch of different things. But that does not alone make a solution. A solution is homogeneous, meaning you can't discern the different parts of a solution. A mixture is heterogeneous and you can discern the differences. So I've got this mixture here of flour and beans and rice, and you can see the beans and the flour. And if I take this mesh strainer, I can pour this mixture into here and I can easily separate these parts. So you see, as I'm tapping it, that flour is coming through the mesh strainer. So I can separate some of that flour, and then I can reach in and I can easily pull out some beans. I can easily pull out grains of rice. This is a mixture. I can tell the difference. I can easily separate the parts. It is heterogeneous. So what is homogeneous? You can't tell when you mix things together in a solution what is what. What do I mean by that? If we wanted to mix some water, and this is just tap water from my sink, and we poured in some iodized salt, and we gave that a good stir. This is going to dissolve. The salt is going to dissolve in the water. And instead of being able to see those individual grains of salt or those granules of salt, this is pretty much going to look like water. So it's cleared up pretty nicely. As it sits here, that cloudiness will go away, and this will basically look like drinking water. These are both technically mixtures, but this is not a solution and this is. So a solution is a more specific type of a mixture. Okay, so let's talk about solvents and solutes. Solvents occur in a solution in a larger quantity. They are the dissolving mechanism, and your solute is what is being dissolved. So in this case, water was our solvent and the salt was our solute. A debatably fun and easy way to remember it, for me at least, is your solvent is dissolving your solute, and your solute says, "Sol you later." So use that if you want to. So our solvent, water, dissolved our solute, salt. What does dissolving mean? Dissolving is the process where your solvent wraps around your solute and actually like covers it up. So that's why you can't see the salt anymore. It's been covered up, it's been dissolved by the water. Now I told y'all that would clear up, and I mean that really does look like you could take a big drink of that and it would be a nice refreshing glass of water, but absolutely it would not be, and I would not do that. Depending on the temperature of your solvent, so our water, you can also dissolve more quickly if your water is warmer. So if your solvent is warmer, it will dissolve your solute more quickly. So let's take a couple of jars here. I have 2 tablespoons of salt in each of these. And I've got some hot water over here on the stove. So I'm going to fill this jar up to about 400 milliliters. And that pours beautifully. I'm glad I moved my cup of salt. So that's hot water. That's 400 milliliters of hot water. And then this is cold water that's been in the fridge. And I'll put about 400 milliliters in here of cold water. And I'm going to pour this salt at the same time. It does look like the hot water has cleared up a lot and there's a lot less salt. I know y'all can't see it. There's a lot less salt granules noticeable on the bottom than there is in the cold. Hold it up. So you can see there's the salt on the bottom. So the water itself is a lot more clear and it has already dissolved more grains of salt in the hot water than in the cold. So as soon as this is all dissolved, I'm going to stop stirring. Okay, so I'm not seeing any more grains of salt in there, but we've still got some floating around in this cold water. And you can see, I think most of the grains of salt have dissolved in here, like the large chunks of salt have dissolved, but you can still see those little floaters where it hasn't cleared up all the way yet. This is a good visual of the hotter the solvent, the less time it takes to dissolve your solute. This is almost all the way clear, so you can see that. You've also got some condensation going on right here, so it's a little bit harder to see because it's fogged up. Okay, well, what happens when you put too much salt or too much solute in a solvent? Then it becomes saturated to oversaturated. So the difference between saturation and oversaturation is when you have absolutely met the limit to the dissolving power of your solvent, you have met saturation, but you still won't be able to see your solute. So it's all dissolving, but if you put any more solute in at that point, it will be oversaturated. So like here, you've got a lot of salt in here, but you can't see it. It's all been dissolved. If I kept putting salt in here and kept putting salt in here, eventually it would stop dissolving the salt and we would have granules at the bottom. So I'm going to take this smaller jar so I don't have to use as much salt, but I'm going to pour some of this hot salt water in here. And I am just going to pour a bunch of salt in here. So salt water and more salt. I'm going to pour quite a bit in here because I really want to oversaturate it. So we have met saturation and we have oversaturated it. There is too much salt in this water. So there's too much solute. The solvent can no longer dissolve. So can you see that at the bottom? That nice line of salt. See there? So this is oversaturated. Your solvent is not going to be able to dissolve any more solute. Can you dissolve liquid in liquid? In most cases, yes. Two liquids that will mix together are called miscible liquids. I've got some grape juice. I'm gonna fill this jar with some water. So I've got two liquids, and I'm gonna pour these together. And these mixed really nicely to where you cannot differentiate what's grape juice and what is water. It's all very mixed together. It's all homogeneous. You've got you a nice solution of water and grape juice. Okay, what if we take water and oil? They're two liquids, but will they be miscible? Will they mix? So we've got water, and this is olive oil. I'm gonna pour a little bit of olive oil in here. Do you see how that olive oil floated to the top of the water? So oil and water don't like to mix. They are immiscible. This is due to the polarity of the water molecules and the oil molecules. We are not going to get into that right now because it's a little bit complicated. But you can see, even after I stirred, you can see how the oil is separating again. It's wanting to float up to the top of the water. That is also indicative that oil has a lower density than water. It's wanting to float. So that buoyant force of the water is overcoming the weight of the oil because it's less dense. So you see there? So oil and water are immiscible. So you've got miscible, mixes together, immiscible, does not mix together. You can also take oil, this is olive oil and vegetable oil, and you can mix these together, and because their polarities are the same, they do mix together. So there you go. You've got some miscible liquids and some immiscible liquids. How about that? I hope you learned something exciting today about solutions, and I hope you'll come back next time so we can keep getting smart, keeping it simple, and learning about STEM. Bye!
Thank you so much for watching. Here are some other videos you might like. And make sure you subscribe so you can see when new videos are uploaded and we can keep getting smart, keeping it simple, and learning about STEM.